Confirm?
Yes, sir.
Yeah. So think of this convex mirror. What all uses can you think of? Where would you want to use a mirror like that, which gives a small image, and it remember that convex mirror always gives an erect image. Somebody was already giving me this example yesterday. Rear view mirror of the car. Right? You understand that?
Yes, sir. Yes, sir.
Yeah. So
Sir, I have a doubt, sir.
yes, tell me.
Sir, what kind of mirror do dentists use?
Dentists would also use this mirror. What is it called? Concave mirror. Because they want to see the enlarged image and they want to see it erect also, of course. They don't want to see inverted image that will, because they're going to keep it very close to the mirror. So they use concave mirror, okay? Convex mirror, convex mirror would give them smaller image, no? So nobody wants to see a smaller image when you're going through such a detail like a dentist. So using for a shaving mirror or dentist, it's the same logic behind that. Okay, concave mirror.
Yes, sir.
Okay. Now about the
Sir.
yes, tell me.
So convex mirror can be used at turnings on roads.
Absolutely, yes. These are the two main uses actually. The rear view mirror of the vehicles. Why do we use convex? Why not concave over here? What would happen if I use a concave mirror for the rear view mirror?
Everything would be enlarged.
No, that's not true.
Inverted.
We won't be able to see the vehicles coming behind. All
Why
the
not?
vehicles.
No, but showing only enlarged image, that's not the thing, right? Even concave mirror can show smaller image, like point size image, smaller image, equal size image. Here also it's slightly enlarged. So why not use concave? What do you think? These scientists or other people who are doing this design, they have made a mistake?
Are inverted, sir, so we won't see upside down image.
Yes, that is one of the biggest reason, because this mirror, when the object is little far away, it shows us inverted image. So do you want to see a bus coming inverted upside down when you're driving a car? No, right? You don't want to see inverted image, people crawling from the sky upside down. No. So seeing an inverted image, that is the bad thing. There's one more problem that, yes, as you said, when these objects are a little far away, they will show little small, but when they come closer, they'll show very, very big image. So if one car comes behind us, that car itself will cover the whole image, the whole mirror. We will not be able to see this the bicycle guy or the scooter guy who's coming besides that car. So you don't want that to happen. You don't want to see very enlarged image of anything. You want to see the whole background, everything behind you, to the left side, to the right side, everything you want to see together. How can that happen? That can happen only when the images are small. And which mirror gives us small images? Small images given by always the convex mirror. It always gives a small image and always gives an erect image. So these two reasons together makes it very suitable for the rear view mirror of the car.
Sir.
Yes, tell me.
So side view mirrors.
Yes, they are also same. So when we say rear view mirror, that rear view mirror is on the side of the car also, and it's in the middle of the car also. All of them are considered as rear view mirror. You are looking at the back behind the car, no? Is that clear? They are all convex mirrors. whether it's a car or a bike, whatever, the rear view mirror, whatever you have, those rear view mirrors, they are always convex. Okay. So yes, because they have, so this wording also you need to make sure you understand. So because the images are always diminished, they have a wider field of view. What does that mean? You are able to see a bigger area within the mirror. That's the reason you choose this. Okay. So use the word. When so you might be asked a question, why a convex mirror is preferred for a rear view mirror. So you should tell that it gives always erect image and it has a wider field of view. We can see because of diminished images, we can see many things behind the vehicle. Okay. And yeah, at the turning also, like some of who was saying that? Pragati, is that you? Did you say that?
Yes, sir.
Okay. So like Pragati was telling, near some corners or bends, even if some of you are living in ETA, you know that besides the Ryan school, there is a mirror, no, at the corner. So that is actually a convex mirror. So that people can see through the bend. It gives direct images, diminished, you have a wider field of view. So all those reasons apply to this also. Okay. Fine. So is the uses of concave and convex clear to everyone?
Yes, sir.
Yes.
Okay. So the next topic which we have to go through, it is the sign convention. So let's talk a little bit about that. Okay. So here. What is the reason? Just let me write it down. So it's a very important topic, sign convention for mirrors. And this sign convention will be applicable equally for lenses also. So make sure you listen to it carefully, understand, and will be when we go through the sign convention of lens, it will become very easy for you. Okay. So we'll go through the sign convention of concave mirror first. In fact, this sign convention is not separate for both of them, but we will see them separately anyway. You see, uh, all of you remember the coordinate system, right? XY plane. Everybody understands this? X-axis, Y-axis.
Yes, sir.
Okay.
Yes,
So
sir.
yeah, that's good. So anything to the right of this Y-axis, anything to the right, you know it will be positive, correct? And anything to the left of this, it will be negative. Same way, when something is above the x-axis, it is positive. Whether it's this side or this side, doesn't matter. Above the thing, above the x-axis, it's positive, and below, it will be negative. So this is the exact same logic you'll be following for the mirrors also. Let me explain how. Okay. I'll just confirm. Everyone understands this?
Yes, sir.
Yes, sir.
Okay. If anybody needs more clarification about this, let me know now.
Sir, I didn't understand.
You didn't understand? Okay. See, this is your XY plane, okay? The coordinate plane. So when you draw the coordinate system to the right of origin on the x-axis, you write the positive numbers 1, 2, 3, 4, and so on, right? So anything to the right, when you have a coordinate, any point is to the right of this, you will always call it as positive, right? It will be positive number. Same way, if anything is to the left of the origin, you will call it as negative. So remember this thing, to the right it's positive, to the left it's negative. Remember this rule, okay? Same way, when you go think about the y-axis, when you go above, it will be 1, 2, 3, and so on. It will be positive numbers, and when you go down, it will be negative, -1, -2, -3. So up is positive, and down is negative. Does that make sense?
Yes, sir.
Okay, so up is positive, down is negative, right is positive, left is negative. So this is a rule which is applicable for mirrors also, and even for lenses. So when let's take one by one, try to understand. Concave mirror. See, now we are going to consider that I'm going to place some object anywhere. Let's say this is my object AB. And if this is the object, the distance of this object from the pole is represented by the letter U. Okay. What is U?
Distance between object and pole.
Yes. And this naming conventions which I'm using, it's not just applicable for concave, but for all the mirrors. So what I'm going to do is I'm going to put this figure a little bit down, and I'm going to write all these things together over here as a note. So U, it's called the object distance. And what is this distance? It's the distance between the object and the pole. Okay. Then somewhere image will be formed. Let's say that place is over here. A dash, B dash. So if that is the case, image distance from the pole to the image, whatever distance we have, that is represented by the letter V. So what is V then? It is the image distance. So same thing, the distance between the image and the pole this time, okay? Okay, so now you understand U and V. Look at this mirror, look at this figure and tell me whether U will be positive or negative. Remember that when I said something to the left or right,
Negative, sir.
yes, it is the, in case of coordinate system, it was the origin. Here pole is your origin. Okay, you should think of anything to the left of the pole should be considered negative. Anything to the right of the pole will be positive. So U is going to be, like you people said, it's going to be negative.
Sir, can you once again say what is that U, sir?
U is the distance of the object. Wherever is the object, no, is that object EB, you keep away from the mirror somewhere this side, no? So the distance of this object from the pole, that is called U, the image distance. You represent it by the letter U. Is it clear?
Yes, sir.
Okay. And you understand V also? What is V? V is the distance
Negative.
of
Yes, sir.
V is the distance of the image. Wherever the image is formed, that distance, whether it's to the left or right, wherever it is, that distance, image distance is called V. Yeah. So somebody was saying something. Go ahead. Anybody has any question, or you want to add something to what I said?
Sir, in this image, V will also be negative only.
Yes, of course it will be, because it is also to the left of the pole, right?
Then, if the object is between focus and pole and its image is on the right side, then the V will be
Positive.
positive.
Yes, very good. Exactly, it will happen. Okay. So in this case, in this figure, U is negative. And when I say use negative, normally, if nothing is given in the question, you would normally consider this kind of drawing, okay? You will draw the figure, draw the object always to the left by convention. You can draw to the right also if you wish, but I will not confuse you by drawing the figure to the right now. Okay, we will just leave it like this for now. Once you get comfortable, then we will see some other orientations later, okay? So if nothing is given in the question, then by default, you'll assume that object will always keep it to the left and it is always kept above the principal axis. That is the normal convention. Yeah, so if the V is to the left of it, then of course V will be negative. But like you people said, sometimes when the object is to the object is kept just hold on, please. Okay, put it for charge over there quickly. Yeah. So what I was saying is, if you have your concave mirror, and if you have placed your object between the focus and the pole, you remember that it would give us the image to the right of the behind the mirror, right? Image will be behind the mirror. So and remember, this is only one possible case where the object is between F and P. For all other cases, U and B both will be negative. For this particular case, you can see U is negative, but B is positive. Okay. And from here to here, this distance, we'll call it as B. Okay, guys, do you understand this? Is it clear, the sign convention?
Yes, sir.
Okay, so I have just blindly told you that positive, negative, U is positive, V is negative, but what it really means, let's try to understand that in more detail, okay? So, for example, if somebody tells you that an object is kept 25 centimeters away from the mirror, from the concave mirror. So they will only tell you 25, okay? And they're telling you that 25 centimeter, this is the object. Okay. So the object is 25 meters away from the concave mirror. Then what will happen? You will consider this as U, but you should not just write 25. You know that for a concave mirror, normally we are going to place it to the left of the mirror. So U is going to be negative. So you have to write it as minus 25 centimeters. So this minus sign is something you will have to put. It will not be given in the question. You have to be very careful about this. Don't just blindly write 25 and move on with the calculation. Understand, all of you, where we are going to use this sign convention?
Yes, sir.
Yes, sir.
So this minus sign or plus sign, whatever it is, it will not be given in the question ever. Very rarely it will be given. So this is something which you have to put. And then if you have to find the image distance, let's say focal length is given as 15 centimeter. Can you people roughly tell me where will the image of this object be?
Between center of curvature and focus.
Okay, so understand that this is focus, this is center of curvature, and the object distance U is minus 25. Where will be the object over here? Which position?
Between
Between C
focus
and
and
F.
Between?
Center of
C and
curvature
F.
and focus, sir.
Yes, very good. Between center of curvature and focus, because focal length itself is 15. So the center of curvature will be how far away?
30, sir.
Yes, it's the double of the focus. So center of curvature is 30 centimeter apart. That means when I said my object is 25 centimeters away, it's somewhere over here, right? Between C and F. And if that is the case, where will the image be? Approximately, and don't want the exact answer. Where do you think it would be approximately?
beyond C.
Yes, of course. It will be beyond C, it will be enlarged image. Remember the ray diagrams? You should be remembering this now. So whenever you see this kind of a case, you should know it by seeing this, you should realize that, okay, image is going to come up over here somehow, okay? And it will be a real inverted image. It will be enlarged image. So since we already understand this logic, let's go on to the next topic quickly with just for this question alone. Just now, yesterday also I showed you this formula, right? 1 by V, 1 by U, and 1 by F. This is a relation between the object distance, image distance, and the focus. This is the relation which you have to remember. So if any two of the things are given, like in this problem which I was showing you here, U is given and F is given. So I should be able to find V. Can you people find it and tell me what is the V value for this particular case? So use the mirror formula. Okay, And remember, this sign convention is not applicable only for U or V, but it's applicable for the focus also. So for a concave mirror, focal length is to the left or to the right? Where is it? Which side is the focal length?
Left.
Focal length is to the left. So is this focal length positive or negative?
Negative.
So you see, I did not put a minus sign over here. So if I had used this calculation, we would have got wrong answer. So we should put this also as negative. Okay, it's important. Now you should be able to find the V value. Find it out and tell me. So you can write it as 1 by V is equal to 1 by F minus 1 by U, which is 1 by minus 15 minus 1 by minus 25. So what is it? 1 by V. Do the calculation, tell me what's the answer. This also I should not do.
Sir,
Yes,
minus 2 by 75.
minus 2 by
75.
yes. So if it is minus 2 by 75, then V is actually equal to what? Minus 75 by 2.
75 by 2.
So which you can see it as minus of 5, 37, 7.5. Is that correct?
Yes, sir.
So this is what we expected, right? It would have been a little bit beyond the C. So C is 30. So 37.5, of course, will be beyond C. And you see it is already, it automatically came to be negative. It means it is telling us that it is to the left of the mirror. Tell me guys, this calculation made sense to you people, and do you really understand now where the sign convention is used?
Yes, sir.
Yes, sir.
Okay, so make sure you go through today's video, okay, again, because this is important to understand the sign convention and how to use it in the this kind of calculation. Okay, and then go through the NCRT book. So you have a weekend with you, so make sure you will go through all the things up to this mirror formula, this topic. Everything we have.
Yes, sir.
So anybody has any questions from today's class?
Sir, I have a doubt.
Yes, go ahead.
Sir, is it important for the aperture of the mirror should be smaller than the radius?
Yes, it will be, because if the aperture is not small, then the relation between the focal length and the center of curvature will not be like this. It will not be exactly in the center of this. But when we say important, it doesn't mean that it has to be like that. It will always be smaller. It can never be bigger than that. Okay, aperture will always be smaller than the no, not always smaller. It can be bigger also, but if that is there, then this mirror formula, the focal length relation, that will not be same. What I mean to say is, we were saying, right, focal length is half of the radius of curvature. This relation is only valid if the aperture is small. For bigger apertures, the focal length may be slightly different at a different place compared to this scenario, what you're seeing here. Does that make sense?
Yes, sir.
All right. Any other questions? Okay, fine then. Enjoy your Sunday. See you on Monday then. Bye.
Thank you, sir. Thank you, sir.
Sir,
Yes, tell me.